You pull your sample from the oven, record the temperature, and move on. You trust the screen. But what if your digital thermometer has been lying to you all week? Today, we are breaking down exactly why your digital thermometer is giving you wrong readings and how to fix it before it ruins your next project. Welcome back to Certified MTP, your trusted source for material testing equipment and lab supplies. In the world of construction materials testing, civil engineering, and laboratory research, temperature is everything. Whether you are curing concrete blocks, monitoring the viscosity of liquid asphalt, or tracking environmental conditions on a job site, you need accuracy. There is a common misconception that because a thermometer is digital, it is automatically immune to errors. People think, it has a screen, it must be exactly right. But digital thermometers are electronic instruments that rely on delicate sensors, voltage references, and wiring. Over time, and especially under the harsh conditions of field testing, these instruments experience what we call calibration drift. Today, we are going to explore why calibration failure happens, the difference between lab and field errors, and most importantly, we will show you 4 specific types of thermometers and how to use them correctly so you never second-guess your data again. So why does a digital thermometer suddenly start giving you the wrong temperature? It usually boils down to 3 major culprits: mechanical stress, thermal shock, and electronic drift. Let us start with mechanical stress. A digital thermometer is basically a computer attached to a sensor. In many probes, especially thermocouples, the sensor is made of 2 very specific types of metal wire joined at the tip. If you constantly bend the wire, kink the cable, or drop the probe on a hard concrete floor, you alter the physical structure of that metal. Even a microscopic change in the wire changes the electrical resistance. Because the computer in the thermometer calculates temperature based on that exact resistance, any physical damage immediately throws off your calibration. Next is thermal shock. If you take a thermometer that has been sitting in an air-conditioned laboratory and immediately plunge it into a highly heated asphalt mix or a freezing liquid, the rapid expansion and contraction of the metals inside the probe can cause permanent microfractures. Over time, repeated thermal shock degrades the sensor's accuracy. You might think it is reading 200 degrees, but it is actually off by 5 or 10 degrees. In materials testing, a 5-degree error can mean the difference between passing and failing a critical quality control test. Finally, we have electronic drift. The circuit board inside the handheld unit requires a steady voltage to translate the sensor signal into the numbers you see on the screen. As batteries deplete, or if moisture and humidity creep into the casing of a non-waterproof unit, the internal resistance of the circuit board changes. This causes the device to naturally drift away from its calibrated baseline. It is also crucial to understand that calibration errors happen differently depending on where you are working. In a controlled laboratory environment, the ambient room temperature is stable. Here, the most common reason for calibration failure is complacency. Technicians use the same thermometer hundreds of times a month, assuming it remains perfectly calibrated indefinitely. But probes age. The internal components naturally degrade over thousands of heating and cooling cycles. In the lab, errors creep up slowly, a fraction of a degree at a time, until one day your data is entirely skewed. Out in the field, it is a completely different story. Field testing environments are brutal. Your thermometer is exposed to direct UV sunlight, freezing winds, rain, dust, and heavy vibrations from sitting in the back of a work truck. Moisture is the #1 enemy in the field. If water gets into the connection point where the probe meets the digital unit, it can short the connection or create a false reading. This is why having equipment specifically rated for your environment is not just a luxury, it is a strict requirement for accurate testing. To combat these errors, you need to use the right tool for the exact job you're doing. Let us walk through 4 incredible products available at Certified MTP, explain what makes them resistant to typical errors, and show you exactly how simple they are to use. First up is the waterproof Platinum RTD thermometer, which measures from -148 to 572 degrees Fahrenheit and comes with a NIST traceable certificate. RTD stands for Resistance Temperature Detector. Inside the tip of this probe is a tiny piece of pure platinum. Platinum is incredibly stable, meaning it does not suffer from the same electronic drift that cheaper metals do. It is highly accurate and perfect for laboratory use where precision is absolute. How to use it? It is incredibly simple. Just power the unit on. Because it is an RTD, you do not need to select a probe type. Insert the stainless steel probe directly into your liquid, soil, or material sample. The key here is patience. Platinum RTDs are highly accurate, but have a slightly slower response time than thermocouples. Wait about 10 to 15 seconds until the digital reading completely stops fluctuating, then record your number. Next is the advanced thermocouple thermometer, specifically for Type K and Type J probes. Thermocouples are the workhorses of the materials testing industry. They are rugged, they handle extreme temperature ranges, and they have an incredibly fast response time. How to use it? This unit has interchangeable probes. First, grab your Type K or Type J probe wire and plug the two-prong connector into the top of the meter. Turn the power on. You must look at the screen and press the mode button to select either K or J so the computer knows which metal it is reading. If you plug in a K-type probe but the screen says J, your calibration will be completely wrong. Once matched, touch the tip of the wire to the surface you are testing, and you will get an almost instantaneous reading. Our third tool eliminates human error and handles long-term monitoring, the 4-channel data logging thermometer. It is perfect for when you need to know exactly what a curing tank did at 3 a.m. when nobody was in the lab. How to use it? Plug in up to 4 thermocouple probes and place them in different spots. Turn it on, set your time interval, like 1 reading every 5 minutes, and press record. You can just walk away. It automatically logs all temperatures to an SD card, giving you a flawless, unalterable spreadsheet of data. Finally, we have the traceable waterproof thermometer. Moisture is the enemy in the field, but this fully sealed unit survives mud, water, and drops while keeping its calibration. How to use it? It is completely straightforward. Remove the sheath, press on, and submerge the metal stem at least 1 inch into your sample for a proper core reading. Because it is a traceable unit, it comes factory calibrated and is completely ready to trust right out of the box. Even with the best equipment, you still need to verify your accuracy. Never assume a thermometer is right just because the screen turns on. You should verify calibration at least once a month or immediately if a device gets dropped. The easiest way is the ice bath test. Fill a cup with crushed ice and a little distilled water. Insert your probe into the center without touching the sides of the cup. Within a minute, it should read exactly 32 degrees Fahrenheit, 0 degrees Celsius. If it reads 34 degrees Fahrenheit, your calibration has drifted and the unit needs adjusting or replacing. Lastly, always store your thermometers in padded cases. Never wrap the probe wires tightly around the device, as this stresses the internal metals and causes mechanical failure. Treat them like precision instruments, and they will give you years of reliable data. Accurate temperature readings are the foundation of reliable materials testing. Don't let a failing thermometer ruin your hard work. To check out the waterproof Platinum RTD, the 4-channel data logger, or any of the other high-quality testing equipment we discussed today, head over to certifiedmtp.com using the link in the description below. If you found this breakdown helpful, please hit that like button, subscribe to the channel, and turn on notifications so you never miss our deep dives into lab and field testing protocols. Until next time, keep testing, stay accurate, and we will see you in the next video.